So we have this gas law here, a problem with the gas laws, and we need to first look, do we use the ideal or the combined gas law? Since we have moles here, we're thinking that it might be the ideal gas law, and we don't have any initial and final. Everything's just taking place at one particular point in time. So we're going to use the ideal gas law here for this problem. So we have a pressure right here. We have a volume. We have moles, that's N. In our equation, R is a constant, and we're looking for the temperature that's going to be in Kelvin, that's T. So that's what we're actually looking for right here. R is always a bit confusing, but in this case, we look at the pressure, 2.0 atm. So we select the value for R that has atm in it. So this is our value for R. We have atm in the units and in our problem. So you'll be given a list of these usually. Choose the one that matches the units here. And the -1 here means that these will actually be in the denominator. So we could move this down here and get rid of the -1s. So this will be the value for R we use here. So we plug everything into the equation. So we see we can cross out moles. That's the same here and there. But let's move all of this, divide both sides by all of this to get T by itself. And that means that everything here is gone. Let's just get rid of it. So that would give us T. Let's recenter. And we have atmospheres here and here, cancel it out, liters here and here. And you can see we're going to end up with Kelvin. Basically, you multiply these and then multiply these and then divide the numerator by the denominator and you'll get the temperature. And that works out to be 146.23. Let's just call it 146.2 here. Degrees are Kelvin. So that's how you do this kind of example problem here, this practice problem for PV equals nRT. You know things went well if all the units cancel out. This is Dr. B. Thanks for watching.